Okay, this video is on scientific notation. And the reason they created scientific notation is because you need a simple way to write really small numbers and really big numbers. And scientific notation takes that into account for us. So, for example, let's say we have 1,600,000. Now that's 5 zeros that you have to write. And there's a simpler way to write this, which is 1.6 times 10 to the, if I had my decimal right here where my pen is, I could count how many spaces it took me, or how many hops it took me to get all the way to the end. So I'd go 1, 2, 3, 4, 5, 6. And I'll try to write it. 1, 2, 3, 4, 5, 6. So that would be 10 to the 6th. 1.6 times 10 to the 6th. And these two are the exact same number. This one is written out in standard form, or standard notation, and this one is in scientific notation. And it also works with really small numbers. So let's do one small number, and I'll show you what it would look like, and then we'll talk about the rules of scientific notation. So let's just say that you had a really small number. Okay, I can't even think how to say this right now, but when I write it in scientific notation, I'm going to write 7.6 times 10 to the, so I'm going to put my pen there where my decimal, where I want my decimal. Notice I put it in between the 7 and the 6. So I'm going to see how many times I have to hop backwards to get to the other decimal. 1, 2, 3, 4, 5, 6, 7. So it took me 7 hops. Now notice this time I was going to the left. So this one would be -7. And that shows that it's a really small number, and the positive exponent shows that it's a really big number. So we're going to write some things down and take real notes on scientific notation. So scientific notation is used for very small numbers. Oops. Let me erase that. Very small numbers and very large numbers. You don't really use it on everyday numbers. I mean, I guess you could if you really wanted to, but there's no reason to. So scientific notation is used for very small numbers and very large numbers. Rule number 1. When you're writing a number in scientific notation, you must use a number between 1 and 10. Well, actually, I guess between 1 and 9, because 10 would be 2 digits. So let's change that. Say 1 and 9. Yeah. Alright, let's leave it 10. But, so it has to be greater than 1, but less than 10. It can't be 10, but it could be 1, so we'll put it equal to there. It cannot be exactly 10 because it has to be single digits. There must be a single digit before the decimal. There must be a single digit before the decimal. There can be more than one after the decimal, but before the decimal it must be a single digit. You can't have 10 because that's 2 digits. But you could have 1, 2, 3, 4, 5, 6, 7, 8, 9. And that would be fine. So let's just show what I'm talking about. Let's say that the numbers were 178. You would have to have this 1.78 because you can only have one digit in front of the decimal. You can have as many as you want after the decimal, but before the decimal it has to be a single digit. So let's practice a couple more of those. So let's say our number was 27854. When we write it in scientific notation, we would have to put our decimal right after the 2. Notice that I only have one digit before the decimal, and then after the decimal I can have as many as I want. So just know that in order for it to be in scientific notation, that has to be true. You have to have one digit, then your decimal, and then all the rest of your decimals. All the rest of your digits. And you don't have to write the zeros if there were zeros. Like if I had zeros here, I wouldn't write them there. I would include them in however many hops I needed to do. So let's try one. Let's go ahead and write this one in scientific notation. Well, we know the first part. And then we're going to say times 10 to something. So imagine that the decimal is right here, which is where we put it. Now we're going to see how many times we have to hop to get all the way to the end. So we're here and we're trying to get here. So let's count. So I'm going to do, let me move my hand. 1, 2, 3, 4, 5, 6, 7. So it took 7 hops. So that would be 10 to the 7th. And it doesn't matter how messy it looks. Like this looks like a little bit of a mess, but it's fine. Anybody could take this and rewrite this number if they understood scientific notation. Let's try another one. Let's say we have 17,890,000. That's good. All right, so if I look at the real digits here, 1789, I'm just going to write those real digits, or significant digits if you want to call them that. So 1789, I need my decimal right here because I can't have anything more than one digit in front of the decimal. And then now I'm going to say times 10 to something, but I have to figure that out. So my decimal is right here, and I'm trying to get to right here. So let's see how far I have to go. 1, 2, 3, 4, 5, 6, 7. I keep choosing 7. I need to come up with a different example. All right, let's try another one. I want you to try this one by yourself first. So 26,000. So try it by yourself first. Pause the video, try it, and then play the video, see if you got it right. I'm going to write the significant digits, which are 26. And my decimal has to go right here because I can only have one digit in front of the decimal. Turns out I have one digit in front of it and one digit behind it in this case, but it doesn't matter. So here's where my decimal is. Here's where I'm trying to get to. So I go 1, 2, 3, 4. 4 hops. So 2.6 times 10 to the 4th. All right, let's try some negative ones. Let's say we had 0.00, I'll put a 0 in front of 2, 1, 7, I keep using the same numbers, 2. Okay. All right, so I'm going to write my significant digits, 1, 7, 2, and I know my decimal needs to be right behind the first digit. So this is where my decimal will be, and this is where I need to end up. So how far do I have to hop backwards? 1, 2, 3. So times 10. But because we hop backwards, we're going left. If you go left, use a negative exponent. So this is going to be -3. All right, I want you to try one. Let's see, 0, 0, 0, 0, 9. Let's do that. All right, so do what you think you should, and then we'll go over and see if you got it right. All right, I only have one significant digit here. I could write 9.0, but I don't need to. So my decimal is going to be right here, and I'm trying to get to right here. So how far do I have to hop backwards? So 1, 2, 3, 4, 5. Had to hop backwards 5 to the left, so it's going to be -5. And it's fine that it doesn't have like 9.2 or anything like that. It's okay. All right, so that's done. What the next video will be is examples from your assignment.